Ignition sequence starts.
Good morning. This is The View in the International Space Station Flight Control Room, as the team of specialists that routinely monitors the systems of the station becomes accustomed to a new normal, a standard crew complement of 7 astronauts and cosmonauts. This week's arrival of the first operational flight of the SpaceX Crew Dragon, with 4 new members of the Expedition 64 crew, moves the space station program into a new era and marks a milestone in the development of the commercial space industry, which is one of the primary goals of the space station program when it started flying 22 years ago today.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Catherine Clayton. This week we make history with the SpaceX Crew 1 launch and docking.
And resilience rises. Not even gravity contains humanity when we explore as one for all.
NASA's SpaceX Crew 1 mission lifted off on Sunday at 7:27 p.m. on the SpaceX Falcon 9 rocket from Launch Complex 39A at Kennedy Space Center in Florida. The spacecraft made history, carrying NASA astronauts Mike Hopkins, Victor Glover, Shannon Walker, and Jackson astronaut Luigi Noguchi to the International Space Station on the first NASA-certified commercial human spacecraft system. The Crew Dragon, named Resilience, successfully docked to the ISS late Monday evening. The astronauts joined the Expedition 64 crew, comprised of NASA astronaut Kate Rubins and Sergei Ryzhkov and Sergei Kuzverchkov of Roscosmos, to begin a 6-month stay on the ISS.
It was an amazing ride. I can't tell you how excited we were when that rocket lifted off the pad, and then the last 27 hours has gone really smooth, actually. And so we are so excited to be here. We are humbled, and we are excited to be a part of this great expedition. And so we are looking forward to the next 6 months and can't wait to get started.
The Crew 1 arrival isn't the only exciting thing happening on the ISS. This week, Expedition 64 Commander Sergei Ryzhkov and Flight Engineer Sergei Kuzverchkov executed a spacewalk. The cosmonauts moved outside the Poise module of the ISS after conducting leak checks of the airlock that was being used for the first time. They relocated an antenna and performed several other tasks to kick off preparations for the undocking and disposal of the Pierce docking compartment. The Earth-facing Pierce will be replaced by the new Russian multi-purpose laboratory module named Nauka, which is Russian for science, that is scheduled to launch in 2021. The cosmonauts received help from NASA astronaut Kate Rubins to suit up and monitor their tasks. This was the first spacewalk for both cosmonauts and the 8th spacewalk of 2020. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
You've heard this flight of the SpaceX Crew Dragon spacecraft, the first commercial spaceship to carry 4 crew members. You've heard it described as the first operational mission of the vehicle. Well, what does that mean? And what will these astronauts be doing in space? And how long will they be there? I know, a lot of questions. Who better than the crew members themselves to answer those questions and more? Meet the astronauts of Crew 1.
I'm Victor Glover, NASA astronaut, Navy commander.
I'm Dr. Shannon Walker, NASA astronaut.
My name is Soichi Noguchi from Japan.
Hi, I'm Colonel Mike Hopkins, United States Air Force and NASA astronaut. I will be the commander on NASA and SpaceX's Crew 1 mission to the International Space Station.
Crew 1 is the designator for the first operational mission of the SpaceX Crew Dragon. So it's a new vehicle.
We are starting the phase where we are flying astronauts. NASA is flying astronauts to the International Space Station on commercial crew vehicles.
We're going to go up and we're going to stay for the full long duration from 6 to 7 months long.
And one thing that's very different about our flight versus Doug and Bob's is we'll have 4 people. How do 4 people live and operate on such a vehicle?
We want to get our Crew Dragon spacecraft to the space station and home safely. Flying the spaceship is one piece. there's also the very important mission of being on the International Space Station.
And of course, once I arrive on the space station, I'll be a board engineer and do lots of science and maintenance and spacewalks, robotics, all kinds of work.
And then at the end of our mission, our stay on ISS, I'll command the vehicle and bring us back home and land, and then at that point it's all done. Well, actually, it's not all done. Once you get back from the mission, you have a long post-flight period. You know, you go through the day-to-day training, the day-to-day operations to get ready for it.
There's the basic competencies, I guess, flying T-38s, the high-performance jet flying that we do, the NBL training, the diving in the full pressure suit, the space suit, to train for spacewalks, robotics training. I'm still taking Russian classes.
The science payloads and also the maintenance tasks and also some of the assembly tasks remain on the space station.
How to handle emergencies on the space station to how you fly the Crew Dragon spacecraft.
We've been going out to SpaceX and working with them from a training standpoint as well as from a development and verification and testing standpoint.
Also, in many ways, having trained in spacecraft and for spaceflight all over the world, training is training, and it's all about the same. You start off with theoretical work and then you move into the practical inside your spacecraft.
You know, it's a great honor, first and foremost, and looking at all their experience, it makes me, one, comfortable that there's so much experience and so many ways that I can learn from them, but at the same time, I want to be ready and able to contribute.
My kids, my wife have said, "You don't go to work anymore, do you?" It's like you go and just play all day, and that's what it feels like when you come here to JSC and you get to train. And it's much more serious than that, right? It has real consequences. But at the same time, you know, I just absolutely love it.
To be able to fly a new spacecraft to our home of almost 2 decades in low Earth orbit is just an amazing accomplishment.
Americans really should be proud of this achievement. But for the rest of the 7.4 billion people, I will open the door for you. This is an international corporation, and all the other people around the world have a chance to ride on this Crew Dragon. So this is a new era.
I think it is just tremendously exciting and fascinating to know that kids are growing up today that have always had people living in space and always had the countries working together for science and engineering objectives.
All for one, crew one for all.
The 4 new expedition crew members who arrived on the Crew Dragon spacecraft will greatly expand the number of hours available for experiments that are done on the International Space Station. Experiments that cover many scientific disciplines, including medical science, that could benefit the more than 5 million people affected by Parkinson's disease. When Alexander Gerst of the European Space Agency worked on an experiment with a certain protein crystal that may hold important insights, NASA astronaut Serena Auñón-Chancellor walked us through what that was like.
Welcome to Expedition 57 on board the International Space Station. Today we're doing some really cool science. This is Alex Gerst over here with me, and we are working on Parkinson's disease. What we're looking at here is a special protein kinase, or protein crystal structure. And the reason scientists have sent it up here to the International Space Station is because these protein crystals tend to grow larger and of much better quality. Parkinson's is a disease that affects over 5 million people worldwide, and scientists are constantly searching for a cure. And what we discovered was that here in the microgravity environment, these crystals really like to grow. So if scientists can better elucidate or clarify the structure, then they're better able to develop an inhibitor drug for Parkinson's. And not only an inhibitor drug, but an inhibitor drug with very few side effects. So what Alex is doing here today is he's obviously working on the wall, is what it seems like here in microgravity, and he is. He's got a microscope above him, and he's got a plate that he filled with this special protein crystal structure just a few days ago. Gave time for those structures to crystallize, and now he's examining them under the microscope, and he's actually interacting real time with the principal investigator on the ground to look at the crystal structure, to help improve the lighting and the clarity, and then also take pictures, which will then be sent back down to the ground. So here on board Expedition 57, we're very proud to be taking part in this experiment. I think in the past few years, scientists have realized that the microgravity environment is such a unique environment to grow things like cells or protein crystals. And it provides a new way to help us look at diseases in a better way, to help us develop new medications for these diseases. And so we're happy to be taking part in this science up here.
The International Space Station is designed to be a laboratory in space that provides benefits on Earth and will teach humankind the things we need to know to explore out beyond low Earth orbit in the years to come, like when we go back to the Moon in just a few years. There are a couple of recent experiments on the station that are building on all of those goals.
Cementing our place in space. Presented by Science at NASA. As your dog drags you around the block for his morning walk, you're probably not thinking about the wonders of the neighborhood sidewalk. But that concrete is pretty great. Next to water, it's the most widely used material on Earth. In the future, concrete may be equally useful off the planet, when humans construct a permanent base on the Moon. They'll need sturdy stuff that can weather bombardments from solar radiation and meteorites. No one wants a crack in their moon base. The key to making out-of-this-world concrete may be to study it out of this world. 2 experiments have taken place aboard the International Space Station, or ISS, to do just that. The Microgravity Investigation of Cement Solidification, or MIX, and Multi-Use Variable G Processing Facility, or MVP Cell 05. Researchers from Pennsylvania State University and NASA's Marshall Space Flight Center are analyzing the study's results. Concrete is a mixture of sand, gravel, and rocks glued together by cement paste made of water and cement powder. And it's not as mundane as it looks. Under the surface, it's quite complex. What goes on there is key to its strength and durability. Yet scientists still don't understand all the details of concrete's chemistry and microscopic structure. Processing methods aren't cast in stone. There's plenty of room for improvement. Alexandra Redlinska, principal investigator for both experiments, says, "Our experiments are focused on the cement paste that holds the concrete mixture together. We want to know what grows inside cement-based concrete when there is no gravity-driven phenomenon, such as sedimentation. It all begins when water is added to the cement. To put it very simply, the cement's molecular structure changes when the cement grains dissolve." Redlinska explains, as the old molecules dissolve, calcium silicate hydrate and calcium hydroxide start to crystallize. Myriads of these tiny crystals form all through the mixture, interlocking with one another and with the other concrete ingredients, such as gravel. The ISS experiments are researching how this all plays out in space. Redlinska says it could change the distribution of the crystalline microstructure and ultimately the material properties. The ratio of the water-cement powder is critical to making the concrete components combine effectively and determining the strength and durability of the final concrete. Will this ratio need to be different on the Moon, where gravity is about 1/6 of Earth's? That's the kind of question the experiment will shed light on. For the MIX experiment, astronauts added water to a series of packets containing dry cement powder, then added alcohol to some of the packets to stop the hydration process at specified times. For MVP Cell 05, astronauts also hydrated dry cement, but for this experiment they used a centrifuge on board the ISS to simulate gravity at a number of strengths, including lunar gravity and Martian gravity. For both experiments, the samples were returned to Earth for analysis. "We're already seeing and documenting unexpected results," says Marshall's Richard Grugel, co-principal investigator for MVP Cell 05. Redlinska adds, what we find could lead to improvements in concrete both in space and on Earth. Since cement is used extensively around the world, even a small improvement could have a tremendous impact. We might even end up with better sidewalks for walking our dogs. For more from the International Space Station, go to www.nasa.gov/ISS-science. For information about other weighty matters, visit science.nasa.gov.
The structure of the International Space Station relies on a series of trusses engineered to withstand the different forces the station may encounter in low Earth orbit. In this demonstration video, astronaut Ricky Arnold explains the significance of these resilient structures and the forces they're up against in microgravity.
Hey there, I'm NASA astronaut Ricky Arnold. Welcome aboard the International Space Station. Today we're going to talk about the Space Station Truss. The truss segment is just about 100 meters from side to side. A truss is a segment or part of the whole integrated truss structure. The trusses are used to support the 16 solar array panels, which provide energy for us, and radiators which get rid of excess heat that builds up inside the space station. The design of the truss involves triangles and beams, which can be seen on Earth in structures like bridges. Why triangles? Well, this is because of their unique geometric properties, their methods of transferring loads, and their spatial openness. Triangles are more rigid than rectangular shapes because they have fewer joints. The larger number of joints in a shape, the more prone that shape is to being impacted by shear forces. What I'd like to talk a little bit about today is some of the forces that can act upon the truss. Well, the first force I want to talk about is compression force. And compression force is just like it sounds, two things coming together. So if we apply a compression force to the truss, what do you think is going to happen? Well, let me go ahead and do it. And you can see right here where the truss would bend. What do you think the opposite force of compression is? Yeah, it's going to be pulling apart. We call that a tension force. And a tension force is what's going to help maybe even rigidize the truss segment, but it also could potentially pull it apart. I'm not going to pull apart this tape measure because we probably need it later for some work we have to do. Now, if you look carefully, this next force I want to talk about is basically kind of like a twisting force, and we call it torsion. And even when I just let go of the tape measure, you can see it will actually start to happen a little bit. You can start to see, because the center of mass is actually right here, where most of the tape measure is located, and when I let it go, the tape measure itself starts to twist just a little bit. Finally, the fourth force that can act along a truss segment is that can occur at a single point where two opposing forces work on a single point along the truss, just like they can upon the Earth's surface. Think about some earthquakes. You can have a plate that is, or along a fault line where one side of the fault line is moving upward or being forced upward while the other side is moving downward. And that force in one point in opposite directions is called a shear force. And we can also have that happen on the truss segment. Something like this. One thing to think about, where do these forces come from? One force, even though we're up here largely out of the Earth's atmosphere, we do still have drag with the Earth's atmosphere, which can impart loads on or impart a force on the truss segment. Another, I already hinted at earlier, is crew working inside. We're up here, we're exercising, we're moving really heavy pieces of equipment around. So we have an amazing engineering team on the ground, and we have specific disciplines their job is to monitor all the forces imparted upon the International Space Station. They keep track of all those various forces I talked about and where they could be coming from, the atmosphere, visiting vehicles, or even things that the crew are doing inside the space station, and to make sure that those forces aren't significant enough to cause any damage to this wonderful laboratory and living space we have up here in low Earth orbit. Thanks so much for joining me today. We'll see you next time. So long.
Future NASA missions, like the ones that will return American astronauts to the moon in just a few short years, are part of the Artemis program. Artemis is bringing together the Orion spacecraft, the Space Launch System rocket, and the ground systems that are needed to launch them both. Take a look at the progress that's being made at NASA centers and contractor locations all across the country. Along with being a platform for scientific instruments to study the Earth, the International Space Station is a place for human beings to get a view of the planet that is unlike any other. The men and women who have been there say the terrific pictures they share with us are still a bit lacking. It seems that seeing the super wide-angle view of the home planet with your own eyes changes your outlook on the world. It did for former astronaut Mike Foreman.
You're strapped into the space shuttle on the launch pad, and the countdown gets to 0, and you feel like you're just in a car wreck because the solid rocket boosters light off, and they give you a kick in the backside like you were just rear-ended at a stop sign, literally, and launch you into space, and 8.5 minutes later you're there and float out of your seat and start taking in those views, which I can't describe. That's one thing I wish I was better at. It was actually describing that experience of being weightless or experiencing the views of the Earth. It's just, so incredible. I was there for 2 space shuttle missions, so I was never there for more than 16 days at a time, but every time I had a spare minute, I would go to a window, take a look out. Spacewalks always seem to be very busy and task-focused events where I got to do this and I got to move over here and do this, and rarely did you have a minute where you could just say, just take a minute and enjoy the view. But there were those minutes every once in a while, and the view from outside the spacecraft, with that full panoramic vision through your helmet visor, was just incredible. So I always kid those astronauts that don't do the spacewalks. I said the view from inside here through this flat window is pretty good. The view from outside is just amazing. You see the colors of blue that you've never even seen before, the shades and hues of blue, and you see that fine, thin atmosphere that protects us. It's just almost overwhelming when you first see it. I think if you're not a conservationist before you go to space, you're at least partly a conservationist when you come back, because when you see how thin that atmosphere is, that protective layer that we have here that allows us to walk around like without a spacesuit on down here, and breathe the air, you think, wow, we really have to take care of this because it does look so fragile from space. I think if we could get all 6 billion people, or however many we have now on this planet, to see that view for just a few minutes, I think the whole planet would change.
If you'd like another look at any of the stories we feature today, you can always find them on YouTube and Facebook. There are the addresses for both sites. While you're there, be sure to look around. Check out all the other cool stuff that's available about NASA and America's human spaceflight program. And when you're interested in good conversation about human spaceflight and exploration, the place to go is Houston, We Have a Podcast. It's our weekly show where we talk to folks about their work in all aspects of space exploration. New episodes go up every Friday. Today, we talk with scientists Joya Massa and Annalisa Paul about the need for future missions out into the solar system to be able to grow food in space for the astronauts, and about the work being done right now to develop the ability to do that. Go to nasa.gov/podcasts for this week's episode. It's where you'll also find all of our previous episodes. In fact, that's where you'll find the full library of all the NASA podcasts, all of which you can also find on Apple Podcasts, Google Podcasts, and SoundCloud.